So, on this chapter, we are going to discuss the figures and some of the terminologies on chapter 7 on IP addressing. Now, let's begin. IPv4 addresses is expressed in binary. Why it's expressed is it was expressed in binary because the computer reads the IP addresses as binary, not on decimal values. IPv4 addresses is 32 bits binary, and it has a 4 octet, 8 bits per dot. Then on this figure, it is the binary value of this IP address, and this is the prefix length, which denotes the subnet mask. Then on this second figure, it is the it is the decimal value of the previous um, binary IP address. Then it binary address is composed of dotted decimal address, which is here. Then then the octet is the eight binary value per dot, and the 32 bit address is the IP address in binary. Then binary is a number system that consists of the numbers of 0 and 1 called bits. Okay, and next, converting. It's just a conversion. Positional notation. Positional notation. The radix of the decimal number is 10. Then the position in number is descending from, for example this 3 2 1 and 0. Then the calculate is radix radix is radix to the power of the position number, which is 3, is equivalent to 1000. This is 200, is 100, and this is 10, and this is 1. The positional value is 1110 and 1. And okay, let's read the meaning. Radix first the first row identifies the number of base. This is the base on decimal. Then the second row consists the position of the decimal number starting with right to left. 0 is the first position, 1 is the second, the support position. Then the calculate n raised to the n raised to the 0 is always 1. Then the positional value is the answer of radix to the power of position in number. Then the second, okay. Then the binary has a base of 2. Then the position in number is 7654321 and 0, 8 bit. Then if you calculate 2 raised to 7, 2 raised to 6, and the positional value is the answer of the base raised to the position number. Then if the binary value is 1, you will add the position value to the rest of the binary. The rest of the position depends on what value is on the binary. If the value is 1, you will going to add the position value to other position value that has one binary number. If it's 0, it represents that the position value is 0. So, okay, let's proceed to the next. Binary to decimal. Wait a minute again. Oops! Oh, God. Internet's so slow. Oh, God, why? I hope it works. Okay, binary to decimal conversion. To convert binary to decimal, you just need to know where the binary value one is. So if you know that, you will going to add the position value of the binary number that has one. For example, uh, here one is on one the first binary value is 1, so it represents 120, and the next is 64, and the rest is 0. So the rest value that has 0 binary number, its positional value will become 0, because if you multiply 0 to its positional value, the result is 0. Then if you multiply 1 to its positional value, it will result their positional value as their positional value. Then what you need to do after that is you will add all the product of the each binary number and positional value. For this, 128 plus 64 plus 0 to the up to the 8 8 place is 0, so the sum will be 192. Next, 1010101000. So the first value is 1, second 0, so its positional value will be 0 if you multiply it to 0. Then next is 1, so we got 32, 128 and 32. And next is 0, so 16 times 0 is 0. Then the next value is 1 times 8 to its positional value, then the answer is 8. And the rest now is 0. So after that, we're going to add 128 plus 32 is equals to 160 plus 8 is equals to 168. And the rest, it's like the previous calculations. Now, next is um, decimal to binary conversion. To convert decimal to binary, just simply um, if the value is greater than or equals to 128, add one here. Then the current value will need to be subtracted to 128 and add zeros and repeat the the difference. The answer for these two will now be compared to 64. If the answer is greater than 64, you add 1 here, then subtract the number to 64. If not, add 0 and proceed to the next until you come up to the very last. You will now successfully compute the binary values for the decimal number. Now decimal to binary conversion examples. It's 1 because 192 is greater than or equals to 128. Then 1 because 192 minus 128 is equals to 64, and so forth and so on. Let's proceed. The network and host portions. The network is the value here at the very left side, the tree, the tree octet, and the last is the host portion. The subnet mask is uh, the IPv4 unique address. Subnet mask used to identify the network host portion of the IPv4 address, and the default gateway identify the local gateway. This is the IP address, and this is the subnet mask. Logical end. On this logical end, we use the logical operator and to compare one to compare one and zero. One and zero will stand on the logical on the truth value true or false, true and false. So if true and true is equals true, if one is equals to true and then zero is equals to four, one and one is equals to one. Zero and one is equals to zero or false and true is equals to false. And 0 and 0 is equals to 0 and 1 and 0 is equals to 0. Then we will going to do an ending here. So the ending will be if 1 and 1 is 1, 1 and 1 is 1, 0 and 1 and 0, okay, we'll have 192 here. Then like this, we'll go, we will use ending operation on all the octet here to get the end result, and we are able to get the network portion, network address. The prefix length. The prefix length is based on how many ones are there on the subnet mask. The next, the network host broadcast address. The network host address and subnet mask refer to a network. A host address, unique IP addresses assigned for a host and devices. The first host address, available host IP address in that network. The host portion always has all zeros and ends with a 1. And last host address, last available host IP address in the network. The host portion always has all ones and ends with a 0. And the broadcast address, all portion has 1. Static. Okay, we will just open the settings, then add an IP, subnet, and default gateway. Then dynamic, to add a dynamic IP address is here. To create, I mean, shit. To add a dynamic, just simply check this radio button here, and obtain an IP address automatically. IPv4 communication is either unicast, broadcast, or multicast. On the previous chapters, we already discussed unicast, broadcast, and multicast, so I will skip it. Uh, skip all of those. It's just the same. It was just the same to other what you call it chapter. And the public and private IPv4 addresses. The uh the internet blocks the private addresses, and the sum of private addresses are ranged on 10.0.0.0 with a prefix length with a subnet mask of prefix length of 8 2 or 10.0.0.0 to 10.255.255.255, and also the 172.16.0.0 with a prefix length of 12 to 172.31.255.255, and the last one is 192.168.0.0 with a prefix length of 16 to 192.168.255.255.2 .255.255. 2255 is only. Next, a special user IPv4 address is a loopback address, or the 127.0.0.0.0 with a prefix length of 8 to 127.255.255.254. Because the 255 is a broadcast. And the link local address, the 169.254.0.0 with a prefix length of 16 to 1 to 169 to 169.255.0.1 to 169.254.254. And the last is the testnet address, which is 192.0.2.0 with a prefix length of 24 to 192.0.2.255. There noted Note that there are also experimental addresses which range from 240.0.0.0 to 255.255.255.254. Then next, legacy class full. The 0.0.0.0 prefix length 8 to 127 is a class A, and the class B is 128. The range 128.0.0.0 with a prefix length of 16 to 191.255.0.0 with a prefix length of 16. Class C 192.0.0.0.0 with a prefix length of 24 to 223.255.255.0 with a prefix length of 24. Here, the maximum number of networks on the first is 128. The second is 16,384, and the last is 2 million. Okay, let's proceed. Classless addressing. Okay, assignment of IP address. There's a different assignment of IP address on the different regions in the world. So let's continue. The need of IPv6 because of the depletion of the IPv4. The IPv6 was a successor of IPv4. To the IPv4, it's 128 address space, but I've already discussed the IPv6 for on my other video. So let's proceed to the next. Okay, here is the coexist IPv4 and IPv6 coexistence. The dual stack, as shown in the figure 1, dual stack allows IPv4 and IPv6 to coexist in the same network segment. It means it let IPv4 and IPv6 both have in this entire network. And the tunneling is it needs the IPv6 only network need a dual stack router to process and to encapsulate the packet of IPv6 inside the IPv4 network. Then the translation, translation is both networks different, and a router is a NAT64 router that can translate that will translate IPv4 to IPv6 and IPv6 to IPv4. Next, IPv6 address representation is represent 120 addresses are 128 bits in length and written a string of hexadecimal values. Every 4 bits is represented by a single hexadecimal digit for a total of 32 hexadecimal values, 84, 8, 84, is hexstat, 8 hexstat. Then preferred format is 8 hex, um, okay, then this is the conversion and prepare format examples. 1, 2, 3, 4, 5, 6, 7, 8. It has 8 hexstats. The next, in creating a what we call it IPv6, we should omit all the leading zeros like this. We will omit the leading zero, so it will be DV8, and it will be zero. We should magtitira dapat tayo ng isang zero. Then this like this and that. Okay, let's proceed. Rule 2 is omit all zero segment. So to omit all segment, we will use a double colon. But we should be wise on using a um, double colon like on this. It is a zero and it is a triple zero. So we use the double colon on the triple to omit the triple zero, not the only one zero. I hope you get the explanation, but it's a pretty good explanation to easily understand how to omit all the segments. The next, IPv6 address type. And IPv6, IPv4 has the address type unicast, multicast, and broadcast. But here it is unicast, multicast, and anycast. Unicast and multicast are the same on IPv4, but anycast is not. An IPv6 anycast address is any IPv6 anycast address that can be assigned to a multiple devices. A packet sent to a anycast address is routed to the nearest devices having that address. So, ang anycast, kahit siya napupunta, basta malapit doon sa, doon sa devices. Pero dapat kapareho ng IPv6. IPv6 length. It's 64 bits. 64 bits. Um, how? Okay. I think it's always 64. Because both of them is 64. I think the unicast address. The unicast address have global unicast, linked local, um, linked local, unique, and unique local. The global unicast address is similar to the public IPv4 address, which is a globally unique. Then a linked local is communicate with other device on the same local link. With IPv6, the term link refers on a subnet. So the link local is a subnet when it comes to IPv4. Then unique local address is unique address. IPv6 unique local address, some similar to private. So the unique local is like a private address on the IPv4 that the internet blocks. So let's proceed. The link local unicast address. The link local unicast address is the first hex set as always range on FEAT to FEBF and enables device to communicate with other IPv6 embedded device on the same link and only on that link. It means only on that subnet, on that network. Next, structure of an IPv6 global unicast address. Mm, oh, my internet is so slow. The structure is there is a wait, the structure is there's a global routing prefix with a 48 bits and a subnet ID with a 16-bit and a 64-bit for interface ID. If you add the global routing prefix and a subnet ID, it will gain a 64. It will result for a 64 bits. So that's why the subnet ID is equals the prefix length is 64. Then next is okay here is the reading global unicast address. It is a compressed and if you and it this is the preferred. This is the not compressed. The prefix for hexstats. So we can see for hexstats and the global routing prefix is the first three, and the subnet and the interface ID. Okay, let's proceed. Static configuration of a global Unicast address. To, to add an IPv6, just type interface giga. Just first type the IPv6 unicast route dash routing is dash routing. Then you can proceed now to interface gigabit and set an IPv6 address like how you're setting on the on IPv4. Just don't forget the no shutdown command after you set an IPv6 address with its prefix length. Okay, let's proceed. Dynamic dynamic configuration stateless. It is some stateless address auto configuration. So method allow device obtain a prefix the IPv6 router without the use of DHCPv6 router. And IPv6 routing is not enabled by default. To enable it, just type on the global configuration mode the IPv6 dash unicast routing. Then the router will send an RA message to give give the I think the global unique global unique address. Then okay, there's an option for router advertisement Slack only, Slack and DHCPv6 and DHCPv6 only. Okay, let's proceed to the other. Then this there are options two is Slack and stateless. The RA will send an advertisement to all the hosts. Then the the host can can solicit a global unicast address to the router, so it will going to send an RA message, and the DHCPv6 solicit to all DHCPv6 server for addressing information for the host. Then the next is EUI64 process and randomly generated. This EUI process is it will get the MAC address and add and divide it into two parts, which it will be divided into o- 24 bits OUI and 24 bits identifier. Then we must insert the 16-bit value FFE in the middle. Then the first flip flip the UL or let's see where it is. Um, the universally and locally bit will be reversed. The last bit, if zero, will change it to one. If one, will be turned into zero. So we were able to get the modified EUI 64 interface ID. But they but also you can generate a random 64-bit number because some of the some of people are very aware that um, if they use their MAC address, there's something that can happen. So the other way is a randomly generated interface ID that the beginning window um that device may use randomly generated interface ID instead of using the MAC address and the EUI 64-bit process. It For example, the beginning with the Windows, it uses randomly generated interface ID. The next, dynamic link local. dynamic link local is the first bit is always FEAT, and the random generated and the interface ID of the and the interface ID. Next, static link local. If you want to add a static link local, just type on the interface of a specific port like gigabit internet 0 over 0, the IPv6 address and the IPv6 address, then add link local to the last part of the command. Then type no shutdown or type exit or no shutdown. It doesn't matter. Verifying is also show interface, but now we on previous commands we use show IP interface brief to show the IP address to the you show the connected IP address. So for this IPv6 we will going to use the show IPv6 interface brief to view the different IPv6 that are on the router or a switch. Then show IPv6 route, show the routing on IPv6, then ping the IPv6 address to check if there's a connectivity there. Almost the same with other with IP but IP configurations, IPv4, but the structure of the IPv6 is very different to the IPv4. But most of the most of the commands that we will going to use are the same, but we will change the, for example, um, IP address, then type the IP address and the subnet mask. On IPv6, type IPv6 address, then the IPv6 address with a prefix length naman. Then assign, okay, solicited node, so it, next, ICMPv4. ICMP4 and ICMPv6 is Internet Control Message Protocol. Uh, IP is the best effort protocol, but it also sent in the event of certain errors. Provide the messages to be sent in the event for a certain error. ICMP is available for both IP versions. And then messaging, okay. Then common ICMPv4 and ICMPv6 is host confirmation, destination of service unreachable, time exceeded, route redirection. Host confirmation is if the echo message was used to determine the host is operational or the echo message is received by the other host. Then the destination or services unreachable. Host gateway packet it cannot deliver. It can use ICMP destination unreachable message to notify the source that it doesn't reach the other host. Then then the destination unreachable codes for ICMPv4 is 0123. Port the tree is the tree number three is port unreachable, protocol unreachable, the number two, number one is host unreachable, then net unreachable and zero. In ICMPv6 it's also similar, but it's slightly different codes. Okay, time exceeded is if the time to live was decremented up to zero and it's not already reached the host, it will send an ICMP message that the packet was discarded. Then then um when the when the host configure obtained to addressing, it will send a solicitation to the to the router, but the router in every 200 seconds it will send an RA route or router addressing to give a global unique address to the host. That's it. And also here, the next ping test, the local stack. Uh, okay, just if you ping 127.0.0.1, it's a loopback ping, so you automatically receive a connectivity. Then testing connectivity to a local LAN. If you test the port, if you test the port, uh, it will give you a reply that you are connected. Ping test connectivity to remote. Um, as long as mm, one FK reach the F1 and F0 to K. As long as the default gateways are correct, you are able to ping the other what we call it, the other host and the other network. So next, the trace route. This will show the trace route on how does the packet hop to the every remote. And round trip time RTT. Okay. If it cannot um if it cannot round trip time is time packet takes to reach the remote host for the response from the host to them. An asterisk is used to indicate a lost or unreplied packet. So you will see it on the MS that there's an asterisk because there's no reply for that packet. The IPv4 detail and IPv6 hop limit, just the same. Then okay, and that's all for this activity. I hope you understand something and thank you.